Welcome to the CSTRO. In this Python tutorial, you are going to learn that how to solve Bernoulli differential equation using Python module called SymPy, and we will also visualize its solution corresponding to the differential equation. So here you can observe that the form of Bernoulli ODE is it's a d by dx of y, and then p is function of x and y is your dependent variable, and qx and y is raised to n. So, and corresponding to this solution, we are going to solve this equation for n equal to 2, and here px equal to minus 2y minus 2y x, and here qx equal to x square. So let's do it. Okay, so for doing that, import libraries. So from SymPy import a star. So this is your global importing, and now define symbols. So you can define symbols, say x equal to symbols, and give as a character say x symbol. So we have defined our symbol x, you can check it, and then you define your function f. So define function f, right, or may y of x. So here just put your y equal to function and give a character f, right, sorry y. So here you can see that if you type y x, this will be your y of x. Now we'll define our differential equation. For that, type here Bernoulli variable, and you can define your differential equation as this equation. So dy by dx minus 2 y by x. So diff you want y of x and you want only first order differential equation, right? So x comma 1 and close it, type here. So first term is here, then you need to add your minus 2 into y of x by x, right, and then equal to x square into y square x, right? So comma and give here x square into y of x square, right? So type your equation and close it for and now it's fine. So here you can see that you got your equation, the equation to solve this. Now solve it. Okay, so now solve it. So for solving it, type here solution variable and type dsolve, pass your equation, and you want to solve for your y of x, right? So solution print, and here you can see that this is the solution. So I can type here print solution of Bernoulli equation is such that, and this is the solution I can see here. Now you got a constant here. Okay, so you need to define your constant. So go here and add here symbol C1 and also here C1. Now you want to like give some value to this C1 to visualize in a plot, so you can put here say solution. You can put here say so you can put say solution dot, maybe in the next line to give C1 as 10, right? So you can put here substitute and then solution dot substitute C1 10, right? So this will give your C1 as a value and you can check it. So you got your function here, right? You can give any number you want or just put it, right? So you can visualize this plot for 10, okay? So for C1 equal to 10, now plot it, okay? So now this is my got solution for your C1 equal to 10. Now visualize now visualize the y of x, right? So for that I will import numpy. So import numpy as np and then import matplotlib dot pyplot as plt. So for plotting, then you can define your say x equal to, I want to go np.linear space, I want to go from -1 to 1 and 100 data points. Similarly you can define your y equal to this function, so 5 into x square divided by 10 minus x raised to 5, right? There should be a small x. Now plot it, okay? So plt dot plot x comma y, you can give some line width equal to 5, you can give color equal to black, okay? So here you can observe that this is the solution of your Bernoulli differential equation for n equal to 2, right? So I can give a title here, I can give title, so plt dot title, you can say solution of Bernoulli differential equation, right? And then you can give your title label plt dot x label, you can make it x, and similarly plt dot y label equal to y, and you can also give legend here, label equal to solution of function of x, and here you can say it is y of x. defined as 5x square minus 10 minus x raised to 5. This is how the solution looks like. You can review the code once again. So we have this equation. We have defined the symbols, and we have defined the y as a function of x. Then we have defined this equation as a Bernoulli equation. We have solved it for your y of x, and then we have give a constant as c1 equal to 10, and then we have used NumPy and Matplotlib to visualize this solution of y of x. So I expect that this tutorial has helped you to gain some insight about how to solve and visualize differential equation using SymPy, solve it using SymPy, and visualize it in NumPy and Matplotlib. So thank you.